Hello, my name is Sebastián Borja Mosquera, Claudia Matamoros, and Claudia Castro. Today is talk about these colligative properties. In chemistry, colligative properties are those the properties of solution and their components that depend only on the number of non-volatile soluble molecules in relation to number solvent molecules and not natural. Generally expressed as equivalent. In chemistry, colligative properties are those properties of solution and their components that depend only the number of volatile solute of molecules in relationship of the number solved molecules and of their natural. Generally expressed as equivalent or equivalent concentration, that is the amount of total particles of soluted and not chemistry composition.
First property in boiling point. The boiling point in this temperate and with the vapor pressure of the solvent or solutions equals the external pressure, and liquid molecules are observed to transform into gas. For example, and an external pressure of an atmosphere, water boils has an evaporation point, and if the external pressure is modified more of less temperature could be required to boil the water.
The next property is freezing point. The application to cool something quickly, make a mixture of ice with salt, or if you are careful, alcohol, and the freezing point will drop and the ice will melt quickly. Despite appearing to have lost the cold, the mixture form will actually be a few degrees below zero and will be much more effective at cooling than the solid ice cubes. The process of lowering the temperature is also helped by the reaction between the water and the NaSl itself, since that is the endothermic reaction, so it needs heat to present. The next is osmotic pressure. Osmosis is the tendency of solvents to move from areas of lower concentration to areas to higher solute concentrations. The effect can be true as a tendency for solvents to dilute, and is the spontaneous passages of solvents from a more dissolution and dilute, that is less concentrate, to a less dilute solution to be more concentrate. When they are separated by a semi-permanent membrane, the osmotic pressure is defined for the pressure required to prevent a passage of solvent through a semi-permanent membrane, and complies with the expression that is more like a formula that is more complicated to explain in a simple video. 1, 2, 3.
Normally about this vapor pressure. No valid liquids achieve interaction between solute and solvent. Thus the vapor this pressure is low. While volatile liquids have a weakened molecular interaction. This increases vapor pressure if the added solute in no volatile and drop in the vapor pressure will occur since reduce the volume of the solvent for the liquid in the vapor phase.